of its accuracy and because of its finishing process. So in this CNC machines, okay, so the entire movements, the movement of the coordinates, okay, so the movements have been controlled by the software program, okay. So whatever the things we have been programmed in the software in terms of the commands, we're going to describe it, okay. So what should be the dimension, the length, the width, so what finishing, the ends, everything will be given through the system for the CNC machine tool, okay. So it's going to follow according to the instructions given in the given program, okay. So it's going to follow the software program which have been done on this particular software. According to that, it's going to start operating the process over there, okay. So this is about the CNC machining process. So what exactly the applications of the CNC machine means? So wherever we have to make out the complicated parts, okay. In other words, the costliest parts, okay. The parts manufactured especially for the aerospace field and the automotive field will be full of costlier items will be there. The components will be of a costlier process, okay. So in order to do the finishing process for those aerospace parts, we'll be using the CNC machine tools. So that's the main application of this CNC machine tools, okay. So the computer available for performing computations and for controlling the purposes, okay. So in case of the CNC machine tools, as I've been telling, manually no need to do anything over there, okay. So everything we have to control through the system itself. So in order to perform the computations, in order to perform the controlling the futures, so everything will be done through the system itself. In the case of the CNC machine tools, it's a precision machine tools, okay. So why we're going to call it as a precision means it's going to give the accurate results for the components, okay. So whatever the things we have been described, it can able to go up to that accurate dimensions, and it can able to get the clear finishing for the parts over here, okay. So these are the basics of the CNC machine tools. So this is the NC machine, okay. The NC machine will be looking like this, okay. So it is used in the earlier period of time, okay. So before coming the CNC machines, we have been using the NC machine tools, okay. So here also the movements controlled by a program in a punch tape, okay. So here we are not using the computers or any other things, okay. By using the punch tape through the program, we're going to control out the movements. So in the case of the NC machine tools, okay, the main disadvantage is, so we can't able to do the editing of the programs once it has been run over there, okay. So editing option is been not available in this NC machines. In order to overcome these NC machines, the CNC machines have been derived over there, and the CNC machines have been existed over there, okay. So that's why they have been using the CNC machine tool. So these are some of the important parts of the CNC machine tools, okay. So the central processing unit, the servo control unit, the operation control panel, the machine control panel, the PLC, and the other devices. These are some of the important components of the CNC machine tools. So next is with the DNC machine tool, okay. As I've been told what exactly is the NC machine. So what is the meaning of the CNC machine and what is the meaning of the DNC machine, okay. So it is a bit advanced compared to CNC machine tool, okay. So in case of the DNC means the direct numerical control, okay. So in direct numerical control, the central computer, okay, the central computer controls the each of the machines. It may be 1 CNC machine, 2 CNC machine, 3 CNC machine, 4 CNC machine, 5 CNC machines, okay. So all these machines have been we can able to control with the help of a direct numerical control machine, okay. So one system is enough to control the operations of all the different machines which will be coming under that, okay. So that is about the direct numerical control machine. So in a distributed numeric control, the central computer links with the computer available at the machines, okay. So whatever the computer available already in the CNC machines, okay, there has been a link to this master computer over there, okay. So we can able to operate direct, we can able to control all the operations in each one of the machines by using the master computer, the direct numerical control, or else a distributed numerical control machine, okay. So by looking over there, we can able to control all the operations of the different CNC machines with the different operations over there. So that is a direct numerical control machine. So the main important components, okay, the main important components of this direct numerical control machines are the central computer, the bulk memory, the telecommunication lines, and the machine tools. Okay, the central computer. So is a central computer, the bulk memory is the numerical lines, simulation lines, and the machine tools. So these are some of the important components of the direct numerical control. So if you're going to compare out the system, okay. So if you're going to compare out the system, okay. So in terms of the description, okay, we're going to compare the computer numerical control system, direct numerical control system, and the distributed numerical control system. So if we're going to take the first comparison process over here, okay. So the production system used, okay. So what type of production system has been used over there? So if you're going to take the computer numerical control, the batch production can able to do this process over here. Okay. So in the batch wise, so in the batch means around 10 pieces, we're going to make us a one batch. Okay. So like this batch wise, the productions we can able to do in the computer numerical control machines. Okay. So in case of the direct numerical control, okay. So mass production, okay. So more than 10, more than 20, more than 30 parts at a time we can able to do with the help of this direct and numerical control system, okay. As well as in case of the distribution numerical control system, very heavy mass production, okay. So where the very heavy mass production we have to be done over there, means then we have to go for the direct distributed numerical control system, okay. So it's bulkier, okay. In a bulkier manner, we can able to do out the parts in this distributed numerical control system, okay. So this is about the first comparison between CNC, DNC, and the distributed network, the distributed numerical control system. So coming to the second important thing over here, okay. So the production system used, okay. Next is a computerization system, okay. So the computerization system here we're going to use in case of the CNC machine tools. The single computer has been used to control the machine, okay. So in the CNC machine, only one system will be present over there, okay. So the single computer has been used to control the entire machine operation over there in case of the CNC. So whereas in case of the direct DNC system, so one computer controls more than one machine. So that is the difference between the CNC and the DNC. Okay. So one master computer can able to control more than one machines at a time. Okay. It may be two, it may be three, it may be four, it may be five, like that. Okay. So more than one means we have to go for the direct numerical control system. So whereas in case of the distributed numerical control system, a centralized computer controls all computers that control a number of machines. Okay. So in this case, it can able to control all computers. Okay. That Sorry, there is some network problem. Okay, so there is some minor network problem. So I'm going to share the screen. Guys, is it visible? Is it visible?
Yes, sir.
Okay, fine. So coming to the programming, okay. So in case of the CNC, it is either manual programming or also automatic programming is possible. Whereas in case of the DNC, so it only takes the automatic programming. There is no manual programming concept in the DNC. So in case of the distributed numerical control, the efficient automatic programming is going to take it over there. So coming to the flexibility, okay. So the flexibility will given in the ascending order, okay. So it will be too good in case of the CNC. The flexibility of the machine will be too good in the CNC. It is better than CNC in case of the DNC, and it is the best in case of the distributed numerical control system compared to all the process, okay. So there is the concept of the flexibility. So next, the memory storage capacity. Okay. So in case of the CNC, is a normal memory storage. In case of the DNC, the bulk memory storage can able to be done. So in case of the distributed numerical control, the very heavy memory storage can able to be done. So the communication lines, there is the normal communication lines. So whereas in case of the DNC, it is having the telecommunication lines. So in case of the distributed numerical control systems, there are super telecommunication lines. So in all the cases, compared to these three important things, the distributed numerical control plays a very important role because of its accuracy, because of its best programming, because of its flexibility, and because of this production system. Okay. At the same time, the cost is also been high compared to all the process. So next, in case of the next comparison, in case of the production product quality and quantity. So we're going to get the ordinarily in case of the CNC. When we're going to compare the other two things, it has been a bit ordinary over here. It has been enhanced in case of the DNC system, and it is tremendous in case of the distributed numerical control system. So the machine control technology, it is the general control. So it is the modern control. It is the smart control. Okay, the smart control concept has been used in case of the distributed numerical control system compared to other two. So the reliability is good in case of the CNC. It is better in case of the DNC, and it is superior than this two important process. Okay, it is too good in case of distributed numerical control system. Next, the feedback system. So it is normal in case of the CNC. It is better in case of the DNC. It is efficient and it is high tech in case of the distributed numerical control system. The performance, okay, compared to these two, the performance is too superior in case of the distributed numerical control compared to CNC and the DNC. Okay, in case of the CNC, it has been a standard. In case of DNC, it is greater, but in case of the distributed, it is a superior over there. Next, the technology use. The technology it has been used over here is the computer aided manufacturing. So in this case, the computer aided design as well as the computer aided manufacturing. So this case, computer design, computer manufacturing as well as the computer aided engineering. Okay, analysis. Okay, all the things have been mixed in case of distributed numerical control system. So the types of system it has been is a hybrid and straight system. It has been distributed in case of the distributed numerical control system. So the backup of the system, it is normal in CNC, it is better in DNC, and it is stronger in the distributed numerical control system. Okay, this concept of comparison is very important for the examination point of view. For the 10 marks, they're going to ask the comparisons. So this how the differences between the three different types of systems over here. So next we'll be moving for the next important concept of the systems. So based upon the classification, based upon the type of motion, okay. So how it's going to move, okay. So based upon the type of motion, how the things have been moved over here means. So how the things have been moving from one point to other point. Okay. So in case of the either CNC or DNC are distributed. Okay. So based upon this motion, we're gonna have the two important type. Okay. So one is a point to point system. The second one is a contouring system. Okay. The contouring system, it has been also called as the continuous path system. So once you guys are going to check out the diagram over here. Okay. So this is the x-axis, this is the y-axis. Okay. So this is the screen where we're going to perform out the things over here. So the starting point will be over here. Okay. So it will be moving from one point to other point with the help of point wise. The motion will be in terms of point to point contact. So the first point over here, the second point over here, the third point over here. Okay. So this is how the tool will be moving from a point to point, and the operation has been performed at each point locations. Okay. So at each and every point is going to perform out the operation over there. So that's how the tool has been moving from one point to the other point. Okay. So this is the point to point positioning control in case of the NC system. So the second important type of classification based upon the type of motion is, so it is of the contouring system or continuous path system. Okay. So you guys can able to check it out over here. Okay. So there is no point to point contact over here. Instead of point to point contact over here, so we're going to have the contouring concept, the continuous path concept, which is the starting point. So it will go moving in terms of the contour process. Okay. So it is not going with the point to point. So it is moving in terms of the continuous path system, and it has been moving in the given direction in order to get the given path over there. So it's not in the point to point. So like how you guys have been used in case of the CAD in the CAD lab, how you guys are going to move the point to point. At the same time, you're going to use the concept of contouring over there. Okay. So how the contouring will be done over there. Okay. So that's how you guys can able to check out the point to point and the contouring system. Okay. So in the diagram, which is clearly visible how the contouring system will be erased over there. In case over here it is the point to point. In case it is the contouring process, continuous path system over here. So that's the first classification over here. So next we're going to have the classification of CNC machine based on the control loops. Getting? So based upon the control loops, how we're going to be able to classify these NC and the CNC machine tools. Okay. So first we have been classified based upon the type of motion, whether it is a point to point or contouring system. The second important classification over here is based upon the control loops. Okay, based upon the control loops, there is of two important type. Okay, so one is the open loop system, the second one is the closed loop system. So the first diagram has been showing the open loop system. It's going to have the controller unit. It's going to send the information to the driver through the motor has been derived out. Okay. So there is no feedback over here. Okay. The feedback concept has been absent in case of the open loop system. Okay. So because of that, we're going to call it as a open loop system. Okay. So input will be getting from one side. We're going to get the output on the other side. Okay. So there is no feedback or else any other things. That concept in case of the open loop system. Okay. So if you check out the diagram in the closed loop system, you guys can able to check it out clearly over there. Okay. How the concept is going to work over here. So almost same as open loop system, but one component has been given extra over there. Okay. So that is the feedback system. Okay. So the main function of this feedback system in this case is it's going to send out the signals. Okay, it's going to give the feedback to the controller unit. Okay, by giving in this manner, what we can able to expect is we can able to express an accuracy point of view. It will be very important by providing this feedback loop over here. Okay, so whatever the input, we're going to get the output. That output has been compared. So whether it is good or bad. If it's good means it's okay. If it's bad means once again is going to send out the signal back to the unit. From there has been derived over there. Okay, so this is about the closed loop system. Okay, So in case by the accuracy point of view, the closed loop system is too good compared to the open loop system because of the feedback system which is present in the closed loop system. Okay. So this is the second important classification of NC bar CNC machine tools based upon the control loops over here. So the third important classification we can able to check it out in the case of the NC bar CNC machine tools. Okay. So in case of the third important classification is based upon the number of axes. Okay. So based upon a number of axes. Okay. So axis, the meaning of the tool path, how it's going to be moved in a given direction. Okay. So in this case, okay. So in this case, it's of a two-axis system. Okay, based upon the number of axes, the first thing is the two-axis system. Okay, so it's going to move in two important directions over here. Get it? So this is the one direction. This is the another direction of a movement of the cutting tool against the workpiece. So this is a two-axis system. It indicates the two important axes either in the given directions, either in the X, Y, or else in the XZ directions. So the one is the two-axis system. So the next important concept over here is that based upon the classification based upon the number of axes. Okay, so in this process we're going to have the three-axis system over here. Okay, three-axis system means, so we're going to have the three directions. Okay, so the X direction, the Y direction, and the Z direction. Okay, so it's going to rotate based upon the three-axis system. So these are the three-axis system of the classification of the NC bus CNC machine tool. So the fourth important classification is this. So based upon number of axis systems, we're going to the four-axis system. Okay. So the same thing. So one will be extra. Okay. So compared to the previous one axis has been extra in case of the four-axis system. So this is the another important one, the five-axis system. So next, the classification of CNC machine based upon the drive mechanism. Okay. So we're going to have the electric drives, we're going to have the hydraulic drives, we're going to have the pneumatic drives. So these are the advantages and the disadvantages of the CNC by CNC machine tools. So we're going to wind up over here. So in the next class, we're going to come out the